Okay. Okay, so what we're doing here, everybody, is going over how to set the pipe between child one and child two in this assignment. So when, okay, what we're trying to simulate is LS piped to WC. So when the parent, which I'm calling your prog, is running after it has also launched and done the processing of LS and WC, this diagram here is what it will look like when all is said and done and the two programs are running along with your prog. So what this diagram shows is that child one has become LS and its standard output has been set to the standard input of child two, which is running WC, and the standard output of child two is going, for simplicity's sake, to the console. So let's take a look at what's going on here. I have three columns, and we're going to talk about, or we're going to list the various steps that go on in your prog and in child one and in child two, but don't be confused, because as I list steps in child one and child two, those steps are housed in your prog, because when the fork takes place, it's still your prog running. It's another process, but it's still your code until at the very end, child one will become LS, replace itself with LS, and child two will replace itself with WC. So an assumption also is in your code, you've got int P, and there are two of them. Okay, so first things first is pipe of P, and you're going to check the return value there. I'm not in this code, so to speak. All right, so now you've got a pipe where P0 is a read side and P1 is a write side. So let's see if I can just recreate this off the top of my head. We're going to do a fork right after that, and that's giving me child one. So child one starts now, and it is only going to be writing to the pipe. So the first thing it can do is close P0. It's going to be writing to its standard output, which is already open with a copy of the parent's standard output. So it needs to close std out, which we know is file descriptor number one. So std out in all caps is a pound define, which resolves to just the number one. Then it's going to do a dupe of P sub 1. P sub 1, remember, is the right side of the pipe. And when doing the dupe, it's going to start at 0 and find file descriptor 0 and find the first available slot in the open file table. And that's going to be std out because you just closed it. All right, so we have just at this point taken care of establishing that connection. Okay. The next thing that we're going to do is we can't leave an extra right side of the pipe open. So we're going to, we're going to pick the right drawing tool and close P1. Now this doesn't wipe out the connection because the connection still lives in file descriptor 1. Okay, then we're going to do some setup, which Brian, I'm thinking, I didn't hear you say you needed help on the setup for exec, so I'm going to gloss over that, okay?
Okay.
Okay, so you're setting up for exec, and then you do the exec. Okay. All right. Now, back to parent, back to your prog. It's really important that it ultimately washes its hands of the pipe itself. It's critical that there's only one process with the read side open and only one process with the write side open. So once the pipe is created, and child 1 is forked, you can now go ahead and fork child 2. That was unfortunate. Child 2, right? When child 2 starts up, it's after, by the way, back to your prog, it's after both forks have happened that the parent can close safely P0 and P1. Okay, so coming up here, it's at this point that your prog has washed its hands of the pipe. So it has cleaned up after itself with respect to the pipe. Okay? Now we had to do it after both forks so that we could be sure that when the children started, they still had access to the read side and the write side. When child 1 started up and is running, it took care of its business. Now let's look at what child 2 does. Child 2 is only going to be reading, so it has no need for the right side of the pipe. It's going to be reading from STD in. So let's close what's there already. And that would be capital letters STD in, which we also know will resolve to 0 for file descriptor 0. Okay, and now we can dupe the read side of the pipe, and the dupe will search the open file table looking for the first available entry, which, because of the previous step of closing STD in, will be STD in because it's now available and it's file descriptor 0. It's the first one to be looked at. Now that the read side of the pipe is where it is supposed to be, we can close, and again, all of the closes are necessary. Things must be tied up in a pretty ribbon and a pretty bow. Okay, so now we can close P0. And now notice the symmetry here. I didn't line them up in the way in my handwriting, but notice the symmetry. Okay, then the setup for exec. and finally the exec. So at this point, I'm about to make a mark on child 2. At the time that we do the dupe of P0, that's creating this connection. And that is the process. Do you have questions?
Parent has to wait through all of this, right? Or your prog,
Oh,
I guess, in this example.
yes. So your prog will have some more steps. Remember, we did the assignment to C1 and C2. So we would wait on C1 and then wait on C2. What I'm not drawing here is the capture of the return code of either C1 or C2. Okay?
Could you, I know because you have to print, if there are multiple processes running, you have to print child 2 returns that, child 1 returns that. Can you
Exactly.
can you do like one of those in between the waits, or do you have to wait for both of the waits to resolve before you print
No,
either of those?
you could print here for child 1, and you could print here for child 2.
Okay.
Or you could print both after both waits.
Okay.
But I actually would suggest doing the print of child 1's info, termination info, after waiting for child 1.
Okay. Then that really helps.
Well, actually, you know what? I'm not going to say that. I'm going to reverse course and see if I can get in here. My erase brush was just a little bit too big. Let's change that. You know why? It's because if you do it that way, it's possible that you could corrupt the output of child 2.
Okay.
So let's print here. And print about C2. And the reason that it can corrupt is, remember, everybody here is related to your prog. So you see that console there? Well, the standard out of your prog is the same console. That's why printing before child 2 has terminated could lead to corrupted output, polluted output, not corrupted, polluted output of C2. You got that?
Yes.
Okay. All right. Other questions?
Um, just a little one. You said in the spec that you wanted to turn in a make file with this. If we just have one .cpp file, do you still want a make file with it as well, or?
Yeah, I can't recall why I would have said that. So just chalk it up to old age.
Okay. Then that's about it. So thank you
Okay.
very much. That really helped.
Okay. All right. Take it easy, Brian.
You as well. Have a good weekend.
Okay. You too. Bye-bye.
Bye.